Okay, this is the next video on instruction set architecture. We're going to look at MSP 430 addressing modes. There are four basic ways to get an operand. These are the addressing modes. The addressing modes basically tell you the register plus the mode. You need to know both of these in order to get where you're going to get your operand. So let's look how this kind of works. There's register mode, which basically what it does is it just operates on the register. There's indexed register mode, which you take with a number in the register and you add an index to it, and that is a memory location which points to a memory, and that memory location is what is operated on. There's register indirect. It's kind of like pointers in C. We'll look at that in a minute. Whatever is in the register is actually an address that points to a memory location, and that's where you get your operand. There's also indirect auto increment, so it's very similar to register indirect, except that after the operation is performed, then the register is incremented by either 1 or 2, depending on whether you're doing a byte or a word thing, and it's ready for the next one. So let's remind ourselves how addressing modes work in C and C++. This will really help you understand assembly language, assuming you understand C. So let's look at what we have here. So on the left, we're going to have the C++ or the C way of doing things. In the middle, we're going to have what the addressing mode is, and then on the right, we'll have the assembly syntax for that mode. So here's what we have to begin with. If you have in your C code, you say int dog and cat, so dog and cat are both integers. And if the compiler stores those integers in register locations, which if that's all you had, it probably would use the register locations because they're the most handy memory for the compiler. This is register mode, and over on the assembly side, you see it's move.w R4 to R5. So it takes whatever's in register 4 and puts it directly in register 5. This is all just working with registers. Nothing fancy about this. This is the simplest type of addressing. This is what you're used to. And over here, on the left, you have cat equals dog. In other words, you put whatever's in dog into cat. Now we have indexed registers, and this is similar to what we have when we're using arrays in C. So if we define a character table, that means we got a bunch of 8-bit data, 100 of them, and we say cat equals table of dog. That would be like what we call indexed register, and over in here in assembly we do move.b, and it's .b because it's a character, that's 1 byte, 8 bits, and it's table, and then instead of in brackets we use parentheses, table R4. So what happens is it looks what's in the number that's in R4, which I assume would be 100, and it goes to that point and finds the 100th value of table, and it puts it in R5 essentially. So that's indexed. So it looks at whatever address is in R4, and that's where it goes. It reads that and it puts that in register 5. So now we have indirect register with pointers. This is really the same thing, but it's another way to similar anyway. It's at last was indexed register, and this is indirect register. So over here in C, you may have forgotten how this works, so let me just kind of emphasize this. Car star cow means cow is a pointer that points to a character type variable, and table is that pointer. So cow is a pointer which has the value of table, and cow points to a character. And then if we say cat equals star cow, that means whatever is the pointer cow is pointing to, so that is whatever address is in table, that is a character, and put that in cat. Now over here in assembly language, the syntax is this. Since it's character, it's a .b for byte. So move.b and then @R6 means whatever's the address that's in register 6, take and put that into register 5. Up here, whatever table was like 100, and then it adds whatever whatever R4 is, which is like dog, to that 100. So it's the whatever the address of table was plus whatever's in R4 goes into it looks for that thing and puts it in R5. Down here it just looks at whatever's in the address of R6 and puts it in R5. Okay, so let's look at indirect auto increment, and that basically it's very similar to what we just had, except it increments the register afterwards. You put a plus here, and over here in C++ you put 2 pluses on the end to tell it to increment afterwards. Now there's immediate too. What you do is you take cat, put the number 100 in cat in C, and over here you just move .w the number 100 into register 5. So that puts the number 100 into register 5. And then we have cat equals star 100. Basically that looks at address 100 and puts whatever's in address 100 into cat. And over here we have move.w ampersand 100 means address 100, and put that in R5. And lastly we have cat equals dog, and so you can also move.w R5 into dog, and dog would have been something that was declared up in your before your .text part of your assembly program. So I'm going to stop right there and let you digest that just a little bit before we come back.